Hi guys, it's Ms. Stewart here with a video today about porosity, permeability, and groundwater. Sorry it's flipped backwards because we're in selfie mode, but porosity has the word pour in it, and it refers to the space that a material has to either hold air or water. So the way we can calculate porosity of different sediments, like we have here, we have sand, we have some mixed aquarium gravels, and then we have this rounded river stones that have obviously been weathered away to be rounded, so they've been in water for a while. So these are all different texture sizes because we have the smaller texture, a little bit bigger, and even bigger. And what we're going to do is see how that affects how much space is in between each little bit of sand or each little bit of gravel, and that can be calculated. So I'm going to try to angle it down so you guys can see what I'm doing. So what we're going to do is we're going to take a measured amount of water and add it to each material. So we'll start with sand, and with the sand, oh, you can hear the bell going. So with the sand, what we're going to do is add, I have measured out exactly 50 milliliters of water. Notice you look at the meniscus at the bottom to find volume. Zoe's my assistant here today. Say hi, Zoe.
Hi, guys.
So you slowly add the water in until it fills all the way up. And I measured each amount. So each one contains about 100 milliliters of sand, gravel, and water. So it's still not wet all the way through. So we got to make sure it's wet all the way through. And then try not to do what I did, which is make it pool on the top. So you can kind of see I accidentally poured a little too much and it pooled at the top. I'm going to try to dump it back in. Super scientific way of getting it back in there. All right, so it looks like now it's completely covering the sand. So I had 50 milliliters. Now if I look at my meniscus, I'm right here. That's 30. So that's 25, 26, 20, 27. So if I want to know how much space was available to hold water and sand, I just do 50 minus 27, which means I had 23 milliliters of space for sand. So we're going to do the same thing for the gravel. I'm going to start with my 50 milliliters. I'm going to fill it till it covers the gravel. It's going to slide on through there. You can see it starting to fill in the space. You got to be a little bit careful not to pour too fast or you'll do what I did last time, which is overflow. All right, I think we're about even with the top of the gravel, maybe a little bit more. All right, so now if I look, there's 30 milliliters left at the meniscus. So that means this one held 20 milliliters of water. And then last but not least, our river stones. So here we go, pouring it in. I'm going to make it to the same level as the other two because these are bigger rocks. So as you might guess, there's a little bit space there. Now this one has 25 milliliters left. So that means this one held 25. So we had 23 milliliters, 25, and 20. So you can see each, and that's the porosity. So porosity, again, is the space that can hold water. This happens naturally when it rains. So when it rains, the space in sediments or and even in a rock will fill with water as the water infiltrates into the soil. And as it does that, there's only so much space. Otherwise, once it fills up, it does what it did here, which it starts to flood over the top onto the next level. So that's porosity. All right, so we're back now to talk about permeability. So permeability is the ability of a rock or a sediment or soil to let water go through. So now we're not talking about just the space, like whether it has space to hold it. We're talking about whether the space will actually let wet water infiltrate in and go through into the next layer or down to whatever's below. Some things are impermeable. Impermeable means no water. So an impermeable surface would be like clay, like modeling clay, or even like granite, something hard, like the desk is impermeable. If I spill water on it, it doesn't go through to the floor, it puddles up on top. But we're gonna look at some permeable materials. Today we've got rounded gravel stones, like we did for porosity. We've got the fish tank gravel, and we've got the sand. So Zoe and I are gonna pour our water, and we're gonna see which one fills to 100 milliliters the fastest, because that would be the most permeable material, the one that wins the race. All right, so ready, set, go. Tell me when yours gets to 100. Ooh, Zoe, yours is at 100 already, so you're good. Oh, my gravel is. But notice my sand. My sand is still percolating down. It's not actually moving very quickly through. So sand, it is permeable. It lets water through, but not nearly as quickly as gravel and rounded pebble stones do. So those bigger sediments, their space is more connected, so they can let water move through quicker. Now, if I were trying to clean my water, let's say like if there was like some sort of toxin in it, I'd actually prefer it to go through the rocks a little bit slower because it'll pull more of that pollution out. But that's your permeability. So permeability is how fast water moves through, whereas porosity was how much water it can hold. And when you're talking about groundwater, you want the rocks to be both. You want it to let water to go move through it so you can take water out and it'll be able to clean water as it moves through. You also want it to be able to hold water because that's what an aquifer does for our groundwater. It holds different amounts of water. So when we talk about the layers, there are three main parts that you need to know. So you've got, let me look at my drawing here. And this is a drawing, and it's even better the fact that it's flipped backwards. So here's the surface. So you got my bunny and my tree, not to scale. The top part of the layers is the zone of aeration. This is unsaturated. There's no water in it unless it just rained or it's really, really, really rainy. Then you have the water table is the dotted line. So that is how much, that marks the top of the water level. So just like when we were watching this fill, that you can imagine that's like the water table. So when you watch this fill up, the water table goes up as water is added. And if we were to take a straw and suck it out, the water table would go down. And that's sort of what we do with wells. So the zone of saturation is that water that's being held in the layer below. And then at the very bottom, you have something impermeable because you want it to stop going down or else it'll just keep going into the earth and then eventually become part of magma. So you want to have something that keeps it at the surface. That way you can have that water accumulate and the water table go up and then the water table go down depending on how much water you're getting from the surface. So that's groundwater.